This is geometry, section 4.4, using congruent triangles. So, review, what does corresponding mean? Corresponding means congruent parts of congruent figures. So if we're talking about two congruent things, so two congruent triangles, for example, the corresponding parts are the ones that are congruent to each other, either the angles or the sides. So if we've got this congruent statement, triangle RAT is congruent to triangle BUG. UB, so what corresponds to UB? Well, UB are the second and first letter, so AR would correspond to UB because A and R are the second and first letter. Angle G, G is the last letter, T is the last letter, so angle T corresponds to angle G. What corresponds to RT? First and last letter, BG. So today we had one final step to the proofs we've been doing with congruent triangles. It's called CPCTC. It means corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. So, what does this mean? If we're given this information right here, so let's mark the diagram. So PN congruent to EG, PN congruent to EG, PG congruent to NE, and we've also got this reflexive side in the middle, PE, so NPE. We got to be careful here about writing the congruent statement. So N to P to E means we're going across the 1 hash mark and then across the 3 hash mark. So we have to do the same thing with the other triangle. We have to go across the 1 hash mark and then across the 3. So this would go GEP. That's how we would match up the letters. So these are congruent by side, side, side. I've got all 3 sides congruent. Therefore, I can now say that angle N is congruent to angle G because of CPCTC. Since the triangles are congruent, so triangles that are congruent have all of their corresponding parts congruent. So these two angles correspond with each other. N is the first letter, G is the first letter. So these two things are congruent because corresponding parts of congruent triangles are congruent. Here, we've got AT congruent to AM, and AN bisects angle MAT, which is this whole angle right here. So since this angle is being bisected, this angle is congruent to this angle, cuts it into 2 equal pieces. We also have a reflexive side here. So triangle MAN now matches up with triangle TAN. And these are congruent by side, angle, side, because we've got 2 tick marks and the rainbow in between the 2 tick marks. So side, angle, side. Therefore, I can now say NT is congruent to NM because we've shown the triangles are congruent, so corresponding parts of congruent triangles are congruent. CPCTC. This one, we've got DO is perpendicular to PN, so we know these are right angles right here. O is the midpoint of PN, so if O is the midpoint of this whole thing, we know that these pieces are congruent to each other. We also have a reflexive side, so we've got this side in the middle right here reflexive. So these 2 triangles are congruent because I've got side, angle, side. So congruent by side, angle, side. How do we match it up? NOD would match up with POD. Triangle POD. So now I can say angle P congruent to angle N. Those are corresponding parts of congruent triangles. Corresponding parts of congruent triangles are congruent. Here we've got AL is parallel to GE. So these triangles are on here because these lines are parallel. So this is a little tricky. We've got these parallel lines. This angle right here and this angle right here are alternate interior angles for these parallel lines. They're on opposite sides of this transversal. This is a transversal. They're on opposite sides of it and they're inside these 2 parallel lines. So alternate interior angles are congruent, and it also gives us that angle L congruent to angle G. We also have a reflexive side right here. So these 2 triangles are congruent because I've got 2 angles and a side. So angle, angle, side. It's not angle, side, angle because the side is not in between the 2 angles. So angle, angle, side. Again, we've got to figure out what matches up with what. So A to L to E, we go from the single rainbow to the double rainbow to the no rainbow. So single rainbow to double rainbow to no rainbow would be EGA. So now we can say AG, this side right here is congruent to LE, this side right here, because of CPCTC. Note that before we can use CPCTC, we cannot use this reason in a proof until we have proven that triangles are congruent using angle, side, 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 angle, angle, side, any of those that we've got. So a few proofs. We've got first here, given AB congruent to CB and AD congruent to CD. So we can probably already see how we can prove these triangles are congruent. We're trying to prove that angle A is congruent to angle C. Well, we don't know anything about any of the angles on here yet. So we do have this reflexive side, so we can state that BD is congruent to itself, BD, and that is a reflexive side. That's the reflexive property. Okay, reflexive. So now I've got three sides congruent for these two triangles. So I can say triangle BCD congruent to triangle BAD because of side, side, side. I'm trying to prove that angle A is congruent to angle C. Well, since angle A and angle C match up on these two triangles that we just showed were congruent, we can say these are congruent because corresponding parts of congruent triangles are congruent. Next one, angle M congruent to angle S. HC bisects angle MCS. So this whole angle right here is being cut in half. So these angles are congruent to each other. Next step, we need to state that we have a reflexive side. HC congruent to itself. Reflexive. We now have enough information to say the triangles are congruent because we've got two angles and a side. It's not angle, side, angle because the side isn't in between the two rainbows. These should be double rainbows here. So it's angle, angle, side. So triangle MCH congruent to triangle SCH, angle, angle, side. Now we're trying to prove MH congruent to SH. Well, we just showed these triangles were congruent. So now I can say those two pieces are congruent. MH congruent to SH because they match up on the triangles. Corresponding parts of congruent triangles are congruent. Next one, EC is congruent to DC. We're given that. We're given that angle E is congruent to angle D. One thing that we talked about at the beginning of this chapter to watch out for is vertical angles. So I've got vertical angles right here. I need to state that those are congruent. Angle ECA, we can't just call it angle C because there's two angles here at C. So we have to say ECA and DCB. Or we could write in a 1 and a 2 and call it angle 1 and angle 2. So these are congruent because they're vertical angles. Third statement. Now we've got enough to show that these triangles are congruent because I've got two angles and a side in between the two angles. So that's angle, side, angle. Triangle ECA congruent to triangle DCB. We're trying to prove EA congruent to DB. Well, these two match up on these two triangles that we just showed were congruent. So corresponding parts of congruent triangles are congruent, means that EA is congruent to DB. Last one, A is the midpoint of TD. So if A is the midpoint of TD and BR, so A is the midpoint of both of these, then we can say that this segment is congruent to this segment. So we need to state that. So TA congruent to AD. We can also say that BA is congruent to AR. BA congruent to AR, since A is a midpoint of both of those segments. So midpoint, A is a midpoint, or definition of a midpoint. Next statement, we've also got vertical angles here. So let's just call this angle 1, and this is angle 2. So we'll say angle 1 congruent to angle 2, vertical angles. We now have enough information to show that these triangles are congruent because we've got two sides and the angle in between. So triangle RTA congruent to triangle BDA by side angle side. Notice that we're trying to prove TR is parallel to BD. Trying to prove these two are parallel. So ways that we can prove lines are parallel we learned in the last chapter are we can say alternate interior angles are congruent, corresponding angles are congruent, same side interior angles are supplementary, or alternate exterior angles are congruent. We don't really have anything exterior because we've got these two triangles inside these two lines. We don't really know anything about the same side interior angles, but we do know this angle now, angle B, is congruent to this angle R. And these happen to be alternate interior angles. So since angle B congruent to angle R, because corresponding parts of congruent triangles are congruent, we can now say that TR is parallel to BD because we just showed that our alternate interior angles are congruent, which means the lines are parallel.